Brother Guy, everybody. Consolmagno is based in the USA, Arizona. Brother Guy is a Jesuit brother, director of the Vatican Observatory and the president of the Vatican Observatory Foundation, whose research studies meteorites and asteroids. He's a native of Detroit, Michigan, received SB, SM degree from MIT, and earned his PhD in Planetary Sciences from the University of Arizona in 1978. Along with more than 200 scientific publications, he's the author of 6 popular astronomy books. In 2014, he received the Carl Sagan Medal from the American Astronomical Society Division for Planetary Science for excellence in public communication in planetary sciences. Today's talk is on the heavens proclaim astronomy and the Vatican. We very much look forward to your presentation. And Azumi-san, just maybe a few words. Thank you.
今日お話しいただくブラザー・ガイ・コンソルマニョさんは、イエズス会士で修道士です。バチカン天文観測所の所長をしておられ、バチカン天文基金の、会長でいらっしゃいます。隕石や小惑星の専門研究を専門としていらっしゃいます。ミシガン州、アメリカ・ミシガン州デトロイト出身で、マサチューセッツ工科大学の修士課程で学ばれ、アリゾナ州立大学の、天文科学で博士号を取っていらっしゃいます。数々の、科学専門分野の出版物を著作があり、一般の人向けの、天文学の著作も表しておられます。今日のお話は、タイトルは天は告げる、天文学とバチカンというテーマで、バチカン天文観測所の100年の歴史を振り返りながら、現在どのような活動をしているのか、そして、バチカン観測所は1582年のグレゴリオの教皇による、暦の改革から始まって活動をしています。教会が天文学を常に支援して天文学を常に支えてきたということを紹介したいと思います。現代の活動についてご紹介します。以上です。Okay, Neil, back to you.
Okay, so shall I start?
Yes, please.
Great.
I think it's okay. Thank you.
Okay. Yes, so I'm the director of the Vatican Observatory, and I'll just say a brief word about it. It's an astronomical observatory. There are about a dozen astronomers from around the world, and we all work, part of us work in the Vatican. I'm there half the year where there's a meteorite collection. Part of us work here in Arizona where we have a telescope. This image of the Horsehead Nebula was one that I took using our telescope. And we are astronomers who work in the world of astronomy alongside our fellow astronomers, representing the Vatican as a city-state, because it's very popular for city-states, nations to have national observatories. Most of my talk is going to be about the history of the observatory and how the Vatican's been involved. I'll have a bit of science to toss in, but I wanted to start, in this sense, dealing with why people associate stars and religion. It's certainly true that many languages use the same word for sky as for heaven. And in English, we have the word heaven and heavens. And as I understand it, even in Japanese, there is a connection between the two words. There are many reasons, but one certainly is that anyone can walk outside and see overhead at nighttime a beautiful sky, a sky which seems to operate under its own rules, whose beauty never dies, whose motions never cease. And it does have this emotional reaction to us to pull ourselves out of ourselves. And it is fascinating to see how Scripture, especially the Old Testament, talks about astronomy. In the Psalm 8, among many psalms, we hear, "O Lord, our sovereign, how majestic is your name in the earth. You have set your glory above the heavens. When I look at your heavens, the work of your fingers, the moon and the stars you've established, what are human beings that you are mindful of them, mortals that you care for them? Yet you have made them a little lower than God and crowned them with glory and honor." Notice what comes through immediately is, first of all, they're aware of a universe much bigger than just planet Earth. Secondly, that the beauty of the stars are still, we are looking at God's creation, not at gods themselves. Unlike other pagan religions that would see the stars and think that we were looking at, the actual gods themselves, the Hebrew Scripture emphasizes that the heavens are the work of God's fingers. There is also this recognition that it can make us feel very small, and yet God is big enough to recognize each and every one of us and bring us to a dignity that is only slightly less than God. All of this is in a scripture that's 2,500 years old. There's nothing modern about this. It is inherent in the way we view the universe. Another favorite for me is this wonderful bit from a minor prophet, Baruch. "O Israel, how great is the house of God, how vast the territory that he possesses. Great and has no bounds, high and immeasurable. Who's gone up into heaven, taken her, brought her down from the clouds?" The stars, later on mentions, shone in their watches, were glad. He called them and they said, "Here we are." They shone with gladness for him who made them. This is our God. No other can be compared to him. That sense of glory, that sense of beauty, and that sense of joy is what gets communicated to us when we look at the sky at night, especially when it's not blanked out with light pollution. There is a very practical sense for why, of course, churches and cultures have also been interested in the stars, primarily because stars are a great way of keeping track of time. The Hebrew calendar was based on months, the origin, and which comes from the English word month, and month, it's the same thing. The motion of the moon every 29 days set the pattern for the Hebrew day and night, beginning of the day, and then the Sabbath every seventh day. There are 7 days in the week, just as there are 7 things that are seen to move in the sky: the sun and the earth and the 5 visible, or the sun and the moon and the 5 visible planets. In more modern times, Pope Gregory XIII, of course, reformed the calendar in 1582, hiring astronomers in the process. And he did it so that there could be a common calendar that anyone could calculate when the movable feasts, which were still based on the Hebrew calendar, would fit into the Roman calendar, which is based on seasons, not on the position of the moon. So that Easter ought to be the Sunday after Passover. Passover is the first new moon in spring. How do you actually calculate that? Well, it's more complicated than you think, because what if it's Sunday in one part of the world and Saturday in a different part of the world when the moon is full? And how would you calculate this if you're in a mission country far away from Rome? The actual decision was to make a calendar that only approximates the first Sunday after the first full moon, after the first day of spring. And it gets it right 17 years out of 18. But it's a formula that's simple enough that it could be carried and calculated by anyone with a little education. One of the great things that came from this, the same year that the calendar reform was pronounced, at the Vatican, a little tower was built on what is actually on top of the Vatican Library. And there's an image of it, in a modern image. It's called the Tower of the Winds because there was a fancy weather vane inside, and one of the rooms had the 4 winds painted on the 4 walls. Well, the southern wall has a tiny hole, and for most of the year, when sunlight reaches noon, it makes a beam of light through that hole, which will then cross the center line. And when it's winter, the sun is low and the light shines in the far wall. When it's summertime, the sun is high. And of course, the position of the sun is slightly different. From that, you can calculate when is exactly the median point. That shows when the first day of spring is, showed that they needed the calendar to be reformed because the Julian calendar before then was off by about 9 days. It's also a demonstration of how the church would use science for a very practical sense, along with recognizing the glory and the beauty inherent in the sky itself. One of the people who helped explain the new calendar to the rest of the world was Christopher Clavius, who was a Jesuit, and so as a Jesuit, I'm very proud of him. He was one of the people who established that mathematics should be taught in all the schools. It wasn't just something for bean counters. It was an art that makes the soul, in some ways, closer to God, draws you out of the mundane, and makes you recognize truths that could be held as being eternal. He's also the guy who came up with a book that calculated when Easter was going to be for every year up to the year 5000. And this is one of those pages which the last time I was in Rome, I copied. It only goes up to 2019 because thanks to COVID, I haven't been able to get back to Rome this year. When we think of astronomy and the church, of course, we also always think of Galileo. In fact, Galileo and Clavius corresponded. They lived at the same time. Galileo got his teaching notes from Clavius, wrote to Clavius asking for a letter of recommendation. This is a page of Galileo's manuscript describing his observations. You can see a little circle with the stars on either side in that manuscript. That was the position of the moons of Jupiter, which he discovered. He was the first person not to look through a telescope, but to look through a telescope nobody was looking at, and to write a good book about it that the rest of the world could understand. And this came out in 1610. He immediately started talking about things he saw in the sun and got into a fight with another Jesuit, Christoph Scheiner, as to who was the first person to see sunspots and what were the nature of sunspots. And they're human, they're astronomers. Like a lot of astronomers, they got into a big argument of who was first. The funny thing is, neither of them were first. It was actually Thomas Harriot in England who was the first person to see sunspots. The difference really in Galileo was not necessarily that he was the first, but that he also had an education in literature so he could write well, and an education in art so he could draw well and see and understand what he was seeing. He was a complete Renaissance man in that sense. And he wrote many books over a long and brilliant career, most of which was a time when the church supported him. It wasn't until 1632 that he was actually brought on trial for saying things that he had been saying for 20 years without problems. And I don't want to turn this into a Galileo talk. I just want to emphasize three things. First of all, he was not an atheist. He was not some 21st century person tied into, thrown back into the Middle Ages. He was a man of his time, and he was a devout Catholic, even after his trial. He was actually never convicted of being a heretic. The sentence was found guilty of vehement suspicion of heresy. When they told him to recant the heresy, he got up and read a statement, which everyone had approved, saying, if there is anything in my writing which is contrary to the truth of the church, I recant it. He never actually said what any of those things could be. The crazy thing is that it probably wasn't the science that the church was mad at him for. Whatever it was, the church was wrong to put him on trial, whatever its reasons, and nobody's really too sure what those reasons were. If you want to really know more about Galileo, I could say, go find a good book. What is a good book? Well, if you go on Amazon, you'll find a lot of books. And if you don't like any of those books, you can try maybe those books. And if you don't like any of those books, you can try reading any of those books. In fact, I think there are about 400 different books about Galileo. Every one of them going to tell you a different story of what really happened, because we don't know. The history is such that there are many different theories. This Heilbronn book, Galileo, is one of the most recent biographies, and I think it does a marvelous job of describing who he was in his times and where he came from. Plus, it's a wonderfully written book. There's also this other book that I put up here by Finocchiaro, and this is fun because it takes all of Galileo's writings and the writings of the people who supported him and the writings of the people who were against him and the transcript of his trial, and it's all translated into English. So if you want to read it yourself, then you can write your own book, because that's what I did. And I wrote a chapter in this book, Would You Baptize an Extraterrestrial?, which has my own ideas, which are probably no better than anybody else's. All of these different theories have come up with, why did Galileo get into trouble? Maybe he believed in atoms, well, except that the person who finally proposed atoms was a Jesuit priest. He made personal enemies. Of course he made personal enemies. He was an Italian. That's what we do. I'm half Italian. I do that too. The philosophers are out to get him. The Jesuits are out to get him. Maybe, but he had great friends among the philosophers and among the Jesuits. His book insulted to the Pope. Well, you can argue whether it really did or not. But the crazy thing is, the manuscript of the book was actually approved by the Pope's personal censor 2 years before the trial, when suddenly they were shocked to find the things that were in the book. I like to think that it has something to do with the politics of the 30 Years' War, which was this enormously destructive war that was raging across Europe exactly at the time that he went on trial. Except it's hard to draw the exact lines. Why did the Pope's political problems with the 30 Years' War lead him to want to put Galileo on trial? Maybe it's just a coincidence. We don't know. One of the fascinating things that's come up in recent here, and this is a friend of mine, Christopher Graney, has written a book about a fellow named Riccioli of the Society of Jesus, who wrote this book 20 years after the trial, describing the different world systems, whether they were the one with the sun in the center or the one with the earth in the center. And the frontispiece of this book shows the balance between the two different worldviews. The fascinating thing is, Riccioli points out that given the science they had at the time, Galileo didn't have the goods. We know today that he was closer to the truth than the people before him, but the observations of the day were not able to prove that. The other great thing in this book that Riccioli does is he names the craters on the moon, which we can observe using the Galileo telescope, and he includes among the names Copernicus and Kepler and Galileo and Aristarchus, people who believed that the sun was the center of the universe. So the church was open to these ideas. He also puts himself in the same part of the moon as Galileo and Copernicus and Kepler, which is kind of interesting. The other thing that comes out during this time is, remember that room in the Vatican that you had a little hole in the bottom? You can actually do this with any dark room. You can have a small hole in the south wall. When the sun comes through, it's like a pinhole camera. The Italian word camera is just room. What people like Cassini did, again, this is 25 years after the Galileo trial, is to go to a big cathedral and use this to actually make a spot on the ground where you could observe the sun, see the sunspots, even try to see if the size of the sun changed over a period of a year, which would tell you something about the motion of the earth and the motion of the sun, the relative motions between the two. It also allowed you to actually measure with great precision the latitude and longitude of where your cathedral was. Cassini was eventually hired by the King of France to map out France, every church in France. And when he presented the first really accurate map of France, the French king said, "I've lost more territory thanks to your map than I've lost in all of the wars that I've lost." The other thing to remember is that by the middle of the next century, Newton's laws had finally convinced people that a system with the sun at the center would physically make sense. It was far past the Copernican idea, even past what Kepler had come up with, elliptical orbits. But when you look in 1760 at the Jesuit College in Prague, on the ceiling is painted all of these little angels looking through telescopes, and every star that they're looking at, of this most wise work of the Lord, every star we're looking at is surrounded by orbits of planets and comets. The church acted at the time of Galileo as the academy. There were no scientific journals in those days. So the church, running the universities where these thoughts came up, had the job of saying, you know, does the evidence hold up? Can we believe this? Or is this pretty sketchy stuff? It was a tough place for the church to be, but it meant that it was engaged in actually using reason to try to understand the physical universe and recognizing that we could get it wrong and that our ideas needed to grow and needed to change. One of the best stories, now we're getting into the 19th century, of how the church was involved in this work is here. This is a diagram of the Church of St. Ignatius, the founder of the Jesuits. The architect of this church was a great rival of Galileo's, Orazio Grassi. And you see in the diagram this beautiful dome, and then you see in the photograph here a photograph of the dome. But if anyone here has ever been to the Church of St. Ignatius, when you walk under the dome, that's what you see looking straight up. It's a little cockeyed. They ran out of money. They didn't have enough money to build a dome. So they put a flat roof there and hired a Jesuit brother to paint the dome in perspective, so that when you're in the front of the church, it looks like a dome, and only when you're walking underneath it that you realize it kind of looks a little lopsided. Why is this important to the study of astronomy? Well, they had built 4 towers, 4 pillars to hold up the dome that they never built. And so on the roof of that church, this fellow, the Jesuit priest Angelo Secchi, was able to build telescopes supported by the pillars. The telescopes eventually were all confiscated by the Italian government when the unification of Italy happened, but you can still see the base of the telescopes there. Secchi did a number of fabulous things with these telescopes. Probably the most important was he put a prism in front of the lens of the telescope, divided the light from every star that he looked at into a rainbow, and noticed the dark lines that indicate gases in the star that the light has passed through. The idea of taking spectra of glowing gases was only about 20 years old at this point. So he was able to actually measure what chemicals were in the stars, something that people had thought would be impossible. But when you think about what he was doing, it's even deeper than that. He was classifying different stars as different types because he saw there were a finite number of different types of stars that repeat themselves over and over again. This stellar classification ultimately is the basis of what we call the Hertzsprung-Russell diagram and the basis of astrophysics. But stepping back even deeper than that, what he really did was to ask a question that no one had asked before. Rather than measuring the positions of stars, which is what national observatories did, so you could have booklets of positions of stars that navigators could take with them to see, so you could measure where the stars are on the boat, compare where they ought to be according to the book, and determine where you were on the seas. That's how people navigated. So positions were what people measured. And Secchi didn't care about where are the stars. He changed the question. What are the stars? And in doing that, he invented modern astronomy. He's probably the greatest astronomer you've never heard of, partly because the English astronomers were very jealous of him and made sure that his books were not translated into English for many years. Secchi did a couple of other things. He was the first person to look at the planets and see markings on the planets and try to describe that the planet Mars might have light regions and dark regions, and who knows what these are. Try to even guess about the geology of another planet. Again, asking what, not just where. And he did a number of observations of eclipses. He was the one who showed, because he was able to photograph eclipses, that the light around the sun during an eclipse is real. It's not just something in your telescope or just something in the Earth's atmosphere, because different people in different parts of the world photographing the same eclipse at the same time saw the same corona of the sun. What's more, he was able to measure that there was a connection between the activity on the sun and magnetic fields here on Earth. It turns out, 150 years later, this is really important stuff, because when there are solar storms and a solar maximum, it can disrupt radio, it can disrupt cell phones, it can disrupt our power grids. For that reason, NASA actually has 2 satellites in orbit around the sun with a package to measure the solar activity. And of course, NASA is full of acronyms. So it's the Sun-Earth Connection Coronal and Heliospheric Investigation Package, which comes up with the acronym SECI. So I think he's the only Jesuit who's had his name turned into a NASA acronym. I'd mentioned that the Italian unification of Italy in the 1870s meant that Secchi's observatory was lost, and he died in 1878. 15 years later, Pope Leo XIII decided to found a Vatican observatory. And he did it so that people could see that the church supported science. There are a couple of things going on then. The idea that somehow religion was against science is not something that goes back to Galileo. It is a modern idea. It's actually a Victorian idea. People thought that, steam engines and electricity were going to solve all of our problems. What do we need religion for anymore? World War II showed that just because you've got really good technology doesn't mean that you necessarily have good morality. The Nazi death camps showed that. The other thing was to represent the Vatican as an independent state, independent of Italy, and therefore they wanted their own national observatory. One of the fun things, of course, is that Pope Leo's coat of arms, as it happens, has a comet in it, which was just coincidence. Anyway, he established the observatory in 1891, and telescopes were put on the walls of the Vatican, and they even built a bridge there so you could walk from one telescope to the other. One of the first things they did was to take part in an international project to photograph the sky to make the first atlas, photographic atlas of star positions. And there were 18 observatories around the world that got identical telescopes. This is the Vatican's version of that telescope. We still have this telescope. And photographic plates were made. Every observatory got a little section of the sky to photograph. Once the photographs were taken, then you needed computers to work out the exact positions of each of the bright stars. Computers in those days were human beings, and the human beings who did it for the Vatican were members of the Sisters of the Child Mary, the novices. Once you're a novice, then you're going to actually want more interesting work than this. But the novices cataloged 50,000 stars in the Vatican plates. Just a tremendous amount of work. The Vatican Observatory is not the only place where church people were involved in science. Of course, we all know about Gregorian Mendel, the inventor of genetics. Most people don't realize that your cell phone has the name of 2 devout Catholics, Mr. Ampere and Mr. Volta. Amps and volts, of course, describe how our electric units work. And both Ampere and Volta were devout Catholics. In the 20th century, one of the most outstanding of Catholic priests was Georges Lemaitre. Here at Caltech, next to Millikan, the fellow who worked out the size of the electron, and Einstein. Lemaitre was a mathematician. He had 2 doctorates, one in mathematics from Louvain and one from MIT in astrophysics. And he could read Einstein's theory of general relativity, the mathematics behind it, the way that you might be able to read a poem. And from this, he recognized that in the mathematics was the possibility that the universe was expanding. He predicted if you look at distant galaxies, you would see them moving away from us. And the more distant they were, the faster they would move. And if you calculate backwards, you can find the one time when everything was squeezed into a primordial atom of infinitely high energy. Other people were very suspicious of him saying that, you're just trying to come up with creator God again. And they made fun of his theory by calling it the Big Bang Theory. The interesting thing I want to get across is that Lemaitre himself knew this is not the same thing as creation. Scripture tells us who made the universe. Science tells us how it happened. But creation from nothing, nothing is not just a vacuum. Nothing is not even space and not even time. Creation occurs not just 13.8 billion years ago, but at every instant, at every time, at every moment, when God continues to will the existence of the universe. Because, of course, our God is outside of space and outside of time. And that's why the Genesis story starts. In the beginning, God's already there. God's not part of the universe. God is supernatural. By the 1930s, the Italian government had finally recognized the Vatican as an independent country, and the light pollution had ruined any chance of doing astronomy in walls around the Vatican. So the astronomers were invited by the Pope to come out to the summer house in Castel Gandolfo, where 2 telescope domes were put on the roof of the summer palace. And for many years, this was the headquarters of the Vatican Observatory. The Pope lived in this palace in the summertime, and the astronomers lived, well, those are the astronomers' offices. And if you can see the little arrow, it's maybe behind my screen, it's behind the little pictures of people. But if you move your pictures over to the other side, there's an arrow pointing to a little window. And for about 15 years, that's where my office was. That's where I did science. And it happened to be directly over the Pope's bedroom, which meant that I had to, not make too much noise when I was working. It also allowed me to say that of all the people in the Catholic Church, I was the only one who was above the Pope. Because the Vatican Observatory had the space here, we expanded our work to include a laboratory to measure spectra. And when popes were in residence, they were able to come and visit us. So Pius XII visiting the Spectral Lab and John the 23rd visiting. Of all the popes, Pius XII was the one who I think was probably the most interested in astronomy because he was an amateur astronomer himself. And John the 23rd, probably the least interested, but he would show up with a bottle of wine when he heard the astronomers up on the roof at the telescope and, come and visit and say hi. What's the work we actually do at the observatory? It's the work of real astronomy. And how do we do that work? Well, we had telescopes on the roof. This is one of those telescopes in Castel Gandolfo, but look at all the city lights. Even there, light pollution has made it impossible to do serious science. So in the 1980s, because the director of the observatory had a connection with the University of Arizona, we came out to a place in Arizona, a dark area where there is a mountaintop that the University of Arizona was building a set of telescopes. And the Vatican Observatory was invited to help collaborate with the University of Arizona to build a telescope there. This is our telescope on the bottom, as taken from the roof of a much bigger telescope, the Large Binocular Telescope, one of the largest in the world. And it's a beautiful sight, and it's a beautiful telescope. And I could go on talking for hours about the telescope. The one thing I'll mention is that the mirror, you can see the light comes from the star. It hits this mirror, which is shaped like a dish, which focuses the light onto a second mirror, which then shines the light through the hole in the first mirror. And it gathers all of this light and concentrates it into a tiny point. Because the point of an astronomical telescope isn't to make small things look big, the way that you would use a telescope on Earth. It's to make faint things look bright. You gather as much light as you can over as much an area as you can and concentrate it into a tiny point. The building has 4 bedrooms so that we can go up there for a week on this mountaintop, use the telescope every night on a beautifully dark area. The light shining here is actually the rising moon. That, what looks like smoke, is actually the Milky Way. And if you know your stars, you can actually recognize that that is the Northern Cross in that picture. I just want to mention, among the many things that having an astronomical observatory does, is it gives us a place to talk to people who might not otherwise know we exist or even be comfortable talking to us. The fellow who took this picture, I happen to know very well. He's a good friend. He's a ferocious atheist and very bitterly anti-religion, but we're different because we're fellow astronomers. He can talk to us. He can see in us, well, not all religion people are evil. And we also still have our headquarters in Rome in the meteorite collection, the work that I've worked on. And every now and then, you know, another scientist, a visiting scientist will come. This particular visiting scientist was so eager to work in our lab that he brought his own white lab coat. You may know that Pope Francis actually has a background in chemistry. The work that we do in astronomy continues, whether it's taking surveys of galactic centers, surveys of galaxies, surveys of meteorites and meteorite physical properties. We have also had a number of people who were experts in the mathematics of the Big Bang. The late Father Bill Steger was a colleague and classmate of Stephen Hawking. They both were at Cambridge in the 1970s. And today, if you look way in the back of this picture, the short guy facing to the right is Father Gabriele Giunti. He's an expert in quantum gravity. And if I were really good, I'd be able to point out also in this picture are 2 Nobel Prize winners. This was a conference that we held at the Vatican, something we do quite often, holding conferences where people can come together and talk about the astronomy in a neutral site. We hold every 2 years summer schools where we bring students, mostly from the third world, to come and have an intense 4-week postgraduate experience of astronomy with some of the greatest astronomers in the world. And these young people grow up to become some of the great astronomers in the world. If you've been following astronomy, maybe a couple of years ago, you remember seeing this marvelous image of the shadow of a black hole. The fellow who led that project was one of our summer school students 25 years ago. To finish this talk, I want to, 5 minutes? I want to give you a sense of why we do this. What do we get out of looking at stars? Pope Leo wanted there to be an observatory to show the world that the church was not anti-science. But there's more to it than that. Pius XI wrote that there is, from no part of creation do you get a more eloquent or stronger invitation to prayer and adoration. We read in the biography of St. Ignatius that he would often pray by going underneath the stars. And of course, Pius XI is the one who brought us out. He was at the first meeting of the International Astronomical Union, which is at the top, and he was the one who brought us out to Castel Gandolfo. Pius XII, out of his family's personal fortune, bought us this telescope, the Schmidt telescope that was built there. And in one of his addresses wrote, "Man ascends to God by climbing the ladder of the universe," which of course is an echo of what St. Paul says in the opening chapter of the letter to the Romans. Since the beginning of time, God reveals himself in the things he has created.
Oh dear brother, I'm sorry, you have more time than I thought. You have about 13 more minutes. So sorry.
Okay, well, trust me, I will not run out of things to say. This is a marvelous photograph of course, St. John Paul. And the fellow with the dark beard, it was me back before my hair turned gray. The fellow next to me was the late Bill Steger. The older gentleman there is Father Sabino Maffeo, who had just turned 98 and is still going strong. And the young fellow there, David Brown, is actually at the telescope right now. He's doing his observations there. During a meeting of the Pontifical Academy of the Sciences, Pope John Paul gave an address and then wrote a letter to go into the proceedings book, where he talks about the relationship between faith and science, faith and religion. And the key is in this quotation I give you here. Science can purify religion from error and superstition. We need to have our ideas corrected and grow. The cosmology of Genesis is a flat earth with a dome. And bigger than that was the God who was able to create all of it. And we've gone through many different cosmologies since then. But the truth of God as creator not only has stayed true, but we appreciate God is a whole lot bigger. If he's more than just building a dome, he's building a universe that's 13.8 billion light years in every direction, and that's only the part we can see. Meanwhile, religion can purify science from idolatry and false absolutes. I think of the question that somebody asked the previous speaker, you know, how do you talk to somebody who says we can never know truth? Does the person who says we can never know truth believe that that statement is true? How do they know? The reality is, and what science needs to learn from philosophy, is that no scientific truth is finished or perfect or eternal. If that were the case, then I couldn't get money to, find new science, right? Science is always approaching truth, just as we in our prayer are always coming closer to God without ever thinking that the journey is finished. That, all right, I got God, I figured him out, don't need to do any more prayer, don't need to do any more study. Of course not. And that's something that science and religion can teach each other. Of the three popes who have come to the observatory while I was there, you can see by now my beard is much grayer. Benedict was the one who I think showed the most interest in the work we were doing in the specific work, and he's also got a tremendous sense of humor. He was, trading jokes with me. But he's also reminding us that the laws of nature are a great incentive to contemplate the works of the Lord. Not just so that we can say how smart we are, but that we have the gratitude to be able to thank the Lord that we are able to approach God, that we are able to recognize God in the things that are created. I mentioned our summer school. Every time we have a summer school, every 2 years, we get a private audience with the Pope. And Pope Francis, at one of the audiences, gave an address where he emphasized this beautiful idea. Scientific research can and should be a source of deep joy. And we go back to the very thing I started with. Why do we look at the sky? Because it gives us a sense of the transcendent. It gives us a sense of joy. Why do I do science? Science can be very painstaking and frankly boring at times, especially when the experiment isn't working right, the equations don't work right, the model isn't working right. Why do I do this? Because when I do finally come to an insight, it is a burst of joy that is exactly the same as the burst of joy when God touches my soul for no good reason at all, except just to remind me that I'm there. I want to do one last thing. First of all, to remind you that there is a Vatican Observatory, and we have a website. Just Google Sacred Space Astronomy, and you can find a website, an online magazine where every day we update with new stories about what's going on in astronomy and some reflections about what it means. But I wanted to end with a story, since I've got 5 minutes, of my own personal journey. I went to MIT, I got the degree, went to Arizona, got the doctorate, went back to Boston. I was a postdoctoral fellow at Harvard and a postdoctoral fellow at MIT. And all of this time, as I'm doing more and more esoteric research, I'm also wondering, Why am I doing this work when people are starving in the world? Finally, I didn't have an answer. Finally, I decided that this was utterly pointless. And it was time to quit astronomy and do something else. This was long before I was a Jesuit. It was long before I'd entered the Jesuits. And so just to do something good for the world, I decided to join the US Peace Corps. I said, send me anywhere you're going to go, just as long as I can do something good for people. And they sent me to Africa. I lived in Kenya for 2 years. It was a life-changing experience. I got to live with people who were poor, with people who were hungry. But the astonishing thing to me was that the people I was living with were not only hungry for food, because we don't live by bread alone. I'd read that someplace. I brought my little telescope. I figure if I'm going to be on the equator and I'm going to be in a dark sky, I want to be able to look at things. And I would set up the telescope every time I'd visit a friend in a village, and everybody in the village would come out and look through the telescope, and they'd see the moons of Jupiter, and they'd go, wow. And they'd see the craters on our moon, and they go, wow. And they'd see the rings of Saturn, and they'd be amazed. And their reactions were exactly the same as my reaction and the reactions of my friends back in Michigan, because that's what human beings do. I had a very clever cat in those days, but my cat never wanted to look through the telescope. Human beings have a hunger, and if you deny somebody the chance to feed that hunger because they're too poor, born in the wrong continent, born of the wrong gender, whatever, you're denying them their humanity. But by telling people that you too can ask the questions that we've been asking since the psalmist wrote about how big the universe was and who am I that God notices me. By giving people this chance, you are confirming their humanity. We learn in the story of Genesis chapter 1 that God deliberately makes the universe, that the universe we're studying is an expression of God, that God did it logically, as orderly as day follows night, that God did it and at every step of the way said it was good. But the climax of creation, the point of why creation occurs, is the Sabbath, the seventh day, when we are invited to take a break from worrying about how we're going to fill our stomachs and contemplate God and his creation. God made us to be astronomers. Thank you very much.
Thank you very much, Brother Guy. It's fantastic. I myself took up engineering because I was inspired by astronomy and Dr. Carl Sagan when I was in college, in university. And I find that after 33 years living in Japan, it's nice to be able to come back to that field of study. And thank you very much for underlining the relationship between the church and science. Often people hear of the church being blamed for attacking science, and many people don't know how to answer. So you've given us some very great ways to answer such questions, and especially in evangelization. So when we maybe meet people who want to talk about science, I believe Pat, we may have one. Sorry, Azumi, there may be one or two questions. Pat, is that correct?
Yes. Do you want me to read them?
Yeah, please do.
Okay. Brother, we have two questions, thankfully from the same person, and I have another one if there's time. June Muyuela says the birth of Christ, I'm assuming the birth of Christ is coming soon. When I first read this, I thought it was going to be another birth, and oh my word. Okay. The birth of Christ is coming soon. For the sake of children, could you please tell us whether the star in Bethlehem, is it fact or fiction? And if it is fact, could you tell us more about it?
I can't. I don't know. What I do know is that it is a story which has excited human beings since it was first told. And it could very well be true. There are hundreds of different explanations. I've got my own favorite. But what is true is what the story of the Star of Bethlehem is trying to teach us. That Jesus Christ is of an order different from anyone who was ever born before. And that all of creation was leading up to that moment. That much is true. And there's all sorts of wonderful things you can draw out of the story, including the question of, why were they using astrology? Because the Hebrews were very much against astrology, against the idea that the stars were somehow controlling our lives. It denies the power of God. It denies free will. And yet, the famous phrase Mazel Tov is literally, may you live under good stars. So it's a very complicated answer. But, until I can get a time machine and a video recorder and go back and ask the wise men themselves what they were looking at, I don't know. And that's okay. Because there are some mysteries you try to solve and some mysteries you just love contemplating. And the longer you think about them, the more you can see and the more you can learn about what the questions actually mean.
All right, thank you. I think, Father, I might present you with the next two questions because you might answer them in a similar way. The first one is from the same questioner as last one, June Muyuela. Brother, can you envision astrology or any of its aligned studies being integrated into theological studies? And then Paul Sheehan says, do you believe God has and still does use the stars to communicate with us? Not in the sense of astrology, but in terms of communicating his word to us.
I will be generous and assume that what June means is astronomy and not astrology. Because thinking that the stars control us is heresy. It's absolutely forbidden in Scripture because it denies the power of God. Studying the physical universe and how it works, what God communicates to us there is his sense of joy, his sense of fun, his sense of curiosity. I'm reminded when I was a little kid, and it was a rainy afternoon, and I couldn't go out and play. I was maybe 10 years old. And so my mother comes out with a deck of cards and we're playing rummy. And as I'm playing cards, I get this, how little kids most of the time live in a world on their own and suddenly they have a grown-up idea that it comes out of nowhere. So I suddenly had this, why is my mom, a grown-up, playing cards with me, a stupid kid? I mean, she could win the game anytime she wants. She's a grown-up. Why is she playing with me? It's her way of telling me she loves me. Why does God set up the puzzles, the games that we scientists get to play? It's God's way of telling us he loves us, and it's God's way of expressing his personality to us. God is a God of surprises. God is a God who plays by the rules, but can nonetheless surprise you by the way the rules actually work out. God is a God who made a universe that is not only nice to be around, but it's logical and it's rational, to the point where we learn in the opening of John's Gospel, in arche eto logos, in the beginning was the word. Well, the word for word is logos, where we get the word logic. In the beginning was logic. The incarnation of God in the universe is logic. And yet, God also makes a universe where when I have to choose which of 5 different possible theories I'm going to study, because I don't know which one's true, I can use as a hint which theory is the most beautiful, which theory is the most elegant, because God makes a universe where beauty and elegance count. And that tells me things about God that I could not have learned in any other way.
Thank you, brother. A reminder to everyone, at the bottom of the screen, there is a Q&A button if you want to submit a question, but no one else has. So I'm going to hit you with one, brother. And not to cut into your book sales, but would you baptize an alien?
And the answer I always give is only if she asks. Because it disarms the question in a sense, but it also reminds you that really, first of all, baptism has to be a choice. It can't be imposed on someone. And secondly, we would have to be able to be in a position where we could communicate with each other. And until that situation comes up, I have a hard enough time talking to my family, much less, an alien from another universe. So until that actually comes up, the question is wonderful, not because I have an answer, yes, we should, or no, we shouldn't, but by asking the question, which is why, I wrote the book about it, you then come up with the deeper question, what does baptism mean? Why do we have baptism? It's only when you see it from a new point of view that you see it in its three dimensions, rather than just the way that we were taught as children.
Well, wouldn't it presuppose baptism, the necessity of baptism would necessitate that race had also fallen? Or would we assume they've fallen because of Adam and Eve?
I don't know. And I'm a Jesuit, I could argue either way. You take one side, I'll take the other. But more to the point, just as in physics, we make the assumption, which seems to be true, that the same laws of physics that work here on Earth also work at Alpha Centauri and any galaxy anywhere else. Physics is physics. The laws of right and wrong and good and evil are going to be universal that way. Any creature that is made in the image and likeness of God, no matter how many tentacles, that image and likeness means that they have intellect and free will. Intellect means that they're aware of themselves and aware of other people, and free will means that they are able to choose to love or not love. And if they have free will, they have the possibility of falling. And if they have fallen, they need redemption. But the redemption story doesn't have to be the same. We've got, in our own culture, the legend of angels, who have a redemption story very different. Jesus Christ did not show up as an angel among angels. Who knows how the redemption story is going to play out?
And for us as Catholics, we know Mother Mary needed redemption also, but she didn't need to sin first.
Yeah. It's a complicated question, and precisely because it makes you ask those questions, it's a fun question to contemplate as a mystery, rather than to say that here's the pat answer.
Thank you very much. I have one other question for you from someone who seems to remain anonymous, but is sitting right next to me. Are there aliens?
I don't know. I don't rule it out. I don't rule it in. One thing I've learned is to never second guess what God can do.
Yeah.
But God also, chose to come in what's called the scandal of particularity as a particular person in a particular time in a particular place. So I'm not going to second guess. If there was evidence, I'd be the first to jump up and down.
And Brother Guy, may I have a question, please? Your current research, what is your area of research now, or what you were really inspired or motivated by? What are you maybe wishing to discover, or,
Right. Well, right now there are 2 spacecraft which have visited asteroids, which are bringing pieces back. One is the spacecraft that the Japanese launched, the Hayabusa 2, and the other is a spacecraft the Americans launched, the OSIRIS-REx. And we are eagerly awaiting those pieces because the asteroids they went to, we think, are the sources of the meteorites. Meanwhile, in our laboratories, we are measuring the physical properties of the meteorites to try to understand how they were put together and to understand how they absorb and emit sunlight and heat. And we hope to actually get pieces from these spacecraft to make the measurements of them to compare against the measurements of the meteorites. we get dozens of rocks falling out of the sky from the asteroid belt hitting Earth every month. Most of them are lost in the oceans, but still, we don't know exactly where they came from. We know they're roughly out in the asteroid belt, but here we've got pieces that a spacecraft has grabbed from this particular spot on this particular asteroid in this particular context. And that will maybe allow us to make, all of these meteorites look like this asteroid, look like this sample. It's very exciting. And of course, we're looking at the Japanese mission is going to return first. It should be getting here in December. We learned so much from Hayabusa 1. One of my visits to Japan before was to attend a meeting planning for Hayabusa 1. And we're excited to be getting samples of Hayabusa 2 soon. The fellow who had developed the project for the OSIRIS-REx mission was my original thesis advisor, who sadly died. So it's now somebody else running it.
Thank you, Brother Guy. I think unless there's any other questions, we've hit time for preparing for our next presenter. Brother Guy, absolutely fantastic. And again, thank you for accepting our invitation to speak. You've given us great fuel for evangelization in Japan, particularly in that eternal debate between science and religion. And I hope to have a chat with you and a follow-up after this particular conference. Again, thank you very much.